If we have the inequality m lesser than or equal to t and t lesser than or equal to w, if m represents the number of oranges you take every Monday and t represents the number of oranges you take every Tuesday, and w represents the number of oranges you take every Wednesday. Now, given that the number of oranges you take every Monday is equal to 6 and the numbers of oranges you take every Wednesday is equal to 6, what value of t will make this inequality to be true? Now, I suggest you pause this video and think about a number that will make this to be true. For m equal to 6 and w equal to 6, what value of t will make this inequality to be true? Now, if 6 is lesser than or equal to t and t is lesser than or equal to w now, which is 6. Now, if the number of oranges you take every Monday rather is 6 and 6 is lesser than or equal to t, which is the number of oranges you take every Tuesday, and if the number of oranges you take every Monday, which is 6, is lesser than or equal to numbers of oranges you take every Tuesday, which is t, and the numbers of oranges you take every Tuesday is the unknown, and it's lesser than or equal to the number of oranges you take every Wednesday, which is 6. Now, the only satisfactory number that will make this inequality to be true is t equal to 6, because we could say for this alone we could say 6 is lesser than or equal to 6, and for this we could say 6 is lesser than or equal to 6. Now, joining these two together, we have that 6 is lesser than or equal to 6, or 6 is lesser than or equal to 6. Now, this is a very useful technique in solving some limit problem, and it is called the squeeze theorem. The squeeze theorem. It says if you have n lesser than or equal to q and q is lesser than or equal to m, that if n is equal to m, means automatically you have q equal to n or q equal to m. Now, let's generalize this a bit. Let's take it from this domain to a lot of functions. Let's look at squeeze theory in terms of functions. Let's clear this a little bit. Let's say we have a function g of x, where x is the independent variable and g of x is the dependent variable. If you have g of x lesser than or equal to f of x, and f of x is lesser than or equal to h of x. Now, if we take the limit as some value of x, let's say x approaches 0 of g of x, let's assume this limit approaches L, and we take the limit as x approaches 0 of h of x, which is this, and if this also approaches 0, now automatically we can say that f of x approaches automatically we can say that the limit as x approaches 0 of f of x should also be L, because g of x is lesser than or equal to f of x, and f of x is lesser than or equal to h of x. Now, in the next video, we are going to be applying this to solving a limit problem, and we're going to apply it into solving the limit as theta approaches 0, or sine theta over theta. Now, before I make the next video, try to figure this out. Thank you.